Hello students. So we shall continue the integer lesson after multiplication and division of integers. Now it is properties of integer under multiplication and division. See, properties in the sense we are going to apply some rules to addition, subtraction, multiplication and division and all. In the same way we are given the name for that. In a various methods how we can add, subtract, divide, multiply and all. In the same way, these are called as properties. In a various method means it is a first property, closure property. Always closure property, what it says, if any integer or if you want to study about a closure, whole number or natural number, any two integers, if you add, if it may be the addition and subtraction, if you add, you must get the same type of number. Here integer, if you are going to adding means you must get a same integer only. If you are adding both an integers, whole numbers means you must get the same whole number only. Here multiplication division we are studying means if you multiply any two integers, you must get the result should be integer only. If you dividing any two integer means you must get the after division integer itself only, then only the closure property says true. So here check by examples. Example number 1, by multiplication we are going to study here. Minus 20 into minus 4 gives, see we know the rule of multiplication, first multiply the numeral and then multiply the sign. 20 into 4 is 80, minus into minus plus, so this plus 80 is an integer here. So then not only by these examples, you can see the second example also, plus 4 into minus 6, 4 6 are 24, 1 is plus, 1 is negative means it is negative, is an integer itself. Then this conclude that for all integers a and b, a into b is an integer. See, after the multiplication you got the integer itself means it is a closure property says true. So by the sentence we can understand integers are closed under multiplication. So you can try for the division also. If you divide any two integer, it should be give the integer itself for all the time, not only in a one cases. So take the example 1 here, minus 8 divided by minus 4. So it can write as like this, minus into minus plus only, you know the multiplication and division of sign, plus 4 ones are 4 twos are, if you want you can cancel or directly divide. So plus 2 is the answer here. So here plus 2 is an integer, we know, positive integer. If you want to go for the second integer, not see from the one example only we cannot conclude the rule. You can take the more than two examples also and try. So I have taken a minus 2 divided by minus 4. See, minus of minus plus only, but 2 ones are 2 twos are. So 1 by 2 is a fraction. We'll call it is a fraction. We will study in the further in the second semester, but 1 by 2 is not actually the integer. So integers are not closed under division. So now go for the second property. Means why we have to study this property means we have to add, subtract, multiply and divide in a various methods, isn't it? That's why we are going to study here. Commutative property same. Always you will know that 2 plus 3 is equal to 3 plus 2. Is it not? 2 plus 3 is also 5. 3 plus 2 is also 5. Okay. See, whenever we are going to adding means it is reversibly addition is true. This is called as a commutative property. On addition, if you are adding means it is addition. On if you are subtracting means it is on subtraction. But here we are going to study about the multiplication and division means we have to multiply two integers In the reverse multiplication also you must get the same answer, means it is a commutative property. You can see the question I have taken -2 into -3 as an example. See what is the answer? 2 3s are 6. Both are minus means plus only. See, if you are taken this is a A, it is a B, means reverse multiply. -3 into -2. So what is the answer? 3 2s are 6. Here also plus 6. So both here also plus 6, here also plus 6. So commutative property is true for multiplication of integers. So you can take the examples. 8 plus 8 into -4 gives -4 into +8. 8 4s are 24, minus only 4 8s are also say 24 same. So by conclusion what we can say, for all integers A and B, A into B should be is equal to B into A. So by this integers are commutative under multiplication. Then we go for check division is equal or not. Okay. So see the example for the division test. -6 divided by -2. Minus of minus plus only 2 ones are 2 3s are. Or 6 is divided by 2 means 3 by 1 is nothing but 3 itself. Okay. The remainder is 0, that's why it is 3. So it is true, but in the reverse process whether it is true or not, we must check always. -2 divided by 6, -6, minus of minus plus only, but 2 ones are 2 3s are, so 1 by 3 again it is a fraction. So by this we can conclude 3 is not equal to 1 by 3. See, 3 is a whole number, sorry integer, it is a fraction, so both are not equal here. Okay, then by this understand integers are not commutative under division. You can check by the more examples. Only from one example I have proven. If it is true, then only we can check by the second example. So see the next property, associative property. Associating means if you are going to take more than two numbers, at that time what you'll do? See, just now I have explained, addition and subtraction of two integer, multiplication and division of two integer. By associating the two numbers we have to solve itself. 2 into 3 into 6 means what you'll do at that time, whether you are multiplying 2 first or you are multiplying second 2 first, then we have to multiply first. Both answers should come same. Then it is called as associative property on multiplication. If you want division, in place of this multiplication sign, substitute the division. Okay. See, here also I have chosen examples. -7 into -2. So I have associated first two here means into +5. Should be the same of if you grouping the second. Okay. So 7 2s are 14. Just multiply the numeral, then multiply the sign. Into as it is, +5 means I keep as it is only. 14 5s are 70. Both are plus, that's why it is answer is +70. So here we have done the example. If you are grouping second two, that's why I have put a square box here. Okay, square bracket. Then so in the square brackets first we have to solve those. So 2 5s are 10, minus of plus minus, then 7 10s are 70, minus of minus plus here. Okay, both answers come same. Then +70 is equal to +70, only same answers come, means the integers are associative under multiplication. You can check by the another examples also here. In the formatically like this we can write A into B, first associating C is equal to A into B into C. If it is comes true, then it is integers are associative under multiplication. So by division you can check it is always not true. See how we can find out the next property says or not true or not. If a closure property says true means then commutative we can check. If commutative is false means obviously nearby next property says no. It is no or yes. Here associative property on commutative property of a division is not true means automatically associative is not true itself. If it is yes only we can check. But usually I have taken example. You can by check here. 4 by 2 is plus 2 only because minus of minus plus. Division of minus 3 have written the same. So 2 by 3 is again the fraction. It is not an integer here. Here we are grouping 2 by 3. Again it is not a integers. So the integers are not associated under division. If associative is not true, okay, we can commutative is not true means it always associative is also not true, it is related each other. Then go for the distributive property. How the associating the numbers to solve the integers by associating two numbers we can solve. By that we can understand. By distributing means whatever the number we are. So for example, if I want to add this B and C, I don't want to add first two of B plus C. Usually the method is Bodmer's theory we have to apply. Bodmer's theory means bracket of division first. We have to solve the bracket first, means bracket, in the bracket we have to solve first, division next, multiplication next, addition, then subtraction. That's why it is called as Bodmer's. Don't get confused, it is not Badmas. Just for fun, it is Bodmer's. Bracket of division, multiplication, addition and subtraction we have to solve. So here we are distributing the bracket terms to the outside terms. By that it should be same. If you are solving bracket first then multiplying, or by distributing also should be same, and over addition or subtraction maybe. In the bracket you can choose any operation, addition or subtraction, both comes answer same. That is called as distributing. What we are distributing? See, A into B plus C. If you are taken the example, this A we are distributing to the B and C. That is called as a distributive. See, when you are solving the integers means if some this kind of problems comes means you can solve by two methods, by solving first bracket and then multiplying, or first distribute to the all then we can add. That is also methods comes in. How it is, what is the distribution? First multiply A and B, whatever the addition between is there, no, it is applicable here. So put the bracket for this, then multiply A and C, because there is a multiplication sign here, that's why for both multiplication. So A we are distributing to B and C here. That's why it is called as a distributive property. I hope you understand. Then solve by examples whether it comes as true or not. See, I have chosen A, B, C as a -8, -2, -1. So I have grouped also. First solve by the usual method. By distributing also it will come same answer or not, we have to check. So solve bracket, -2 plus of -1 means -3. So -8 into -3 is +24 itself. So then here you can check by distributing it is correct or not. A into B means minus 8 into 2. 8 2s are 16 positive. Both are having positive sign, positive only. Minus 8 minus 1 means 8 ones are 8, positive itself. 16 plus 8 is 24. Is it not? Same came the answer, no? Then, so integers are distributive under multiplication over addition because we have chosen here as a positive sign. That's why. If you want to check by the subtraction, you can take the same number. Okay. Minus 8 into minus 2. Minus of minus 1 I have taken. Okay. Minus 8 keep as it is into solve this. Minus 2 minus of minus plus 1. Minus 8 as it is. Minus 2 plus 1 is minus 1. So answer is plus 8. Okay. Keep remind it. Answer came is plus 8. So if you distribute after also should come plus 8 itself. So after distribution, what is the answer? Minus 8 into minus 2. Subtraction, because we are over subtraction we are doing. Minus 2 of minus, 8. Minus 8 into minus 1. Minus 8 into 2 is plus 16. Okay. Again minus keep as it is. 8 ones are 8, positive. See, 16 minus 8, how much? Is it not positive 8? Before also came positive 8. That's why integers are distributive under multiplication over addition and subtraction is true. Okay. Now distributive of division over addition. See, usually associative property of a division is not true in the sense almost all next property is also not true. If you taken in place of multiplication, if you taken division here, means it is not true. By solving first bracket, here both brackets, then adding means it is not actually true. By these example we can understand. So next is very important, multiplication and division with a 0. See, if you want to multiply minus 2 into 0. Array, we have multiplied 2 ones are 2, 3 ones are 3. Like that, so many number we have multiplied in the table also. We got the answer. Then what about multiplication with 0? With any integer. It is always 0. So in generally, if you multiply a into 0 or a 0 into a in the means any integer can take. Not only a means if maybe that minus 2, minus 20, plus 25, like this, so many integers if you want to choose and means 0 into that number or that number into 0 gives always 0 itself. So by this you can understand. Here I have some of examples I have written here. You can go through it. Okay. Then what about the multiplication? See the multiplication, division. It is very important. See, multiplication reversibly also it is 0. But here there is a note. I have taken here first note only I'll take. See, when integers are in division with the numerator, so numerator 0 gives always 0 only. Of with the denominator some integer if you have taken. Numerator, see 0 is containing in the numerator and denominator is any integer gives 0. But it is reverse. That means if denominator is 0, then the division goes meaningless. Okay, minus 2 divided by 0 is meaningless or no meaning here. If you go for the higher study means PUC science, if you are chosen at that time you are studied as infinitely. But here understand it is no meaning or not defined also we will call it is. In a 10th standard, it is not mentioned as a not defined. But 0 by anything is 0. So it is dealing with the 0, how we have to study. Now multiplicative identity and division identity. What is the meaning of identity? Just now I have explained in the previous video. Additive identity I have explained. Means additive means we are going to add some number with some number. You must get the same number. Means if I have taken 2 as an example, if you are going to adding to 2 of any number, you must get the same 2 number itself. Then what is this number? See, this is additive identity. That's why it is called as additive identity. By which number if you add to 2, you'll get a 2. Is it not 0? So that's why it is additive identity. Then multiplicative and division. In the subtraction, there is no subtractive identity. Don't search anywhere because it gives the negative answers. So wrong. It is only usually multiplicative identity and additive identity we will say, but division also have taken extra here. So multiplicative also, if you want to multiply 3 with the one number, you must get 3. Which is that number? Choose it. Is it not 1? So then the 1 is called as multiplicative identity. Not only 3, minus 4 you take, into minus 4 only you must get. Is it not 1? So 1 is a multiplicative identity. So that's why I have explained it very clearly. An integer multiplied or divided with any integer, says A, gives the same integer, then it is called as multiplicative identity or division identity. Here I have taken the examples. Multiplicative identity, minus 2 into 1 is minus 2 is any integer, minus 2. Minus 6 into 1, minus 6, plus 8 into 1, plus 8 only. So same integer you have getting means the 1 is called as multiplicative identity. Then division identity is also same. See, minus 4 divided by 1, minus 4 only. See, anything divided by 1 gives means it is same number. That's why division in identity is also 1 itself. Okay. I hope you understand this properties. See, properties means it is not behatting the things. What are the methods to solve when addition, subtraction, multiplication, division, if more than 2 or 2, more than 3 numbers, addition, subtraction, multiplication, division, such kinds of together comes means how we can solve by associating or by commutating or distributing. Like this, we have to think that method we have to apply to solve or to get the answers to simplify the integer solutions. Okay, those are called as a properties. Oh, so I hope you understand. Thank you. In the next classes we can solve the exercise problems. Study well. I'll give you the homework. Thank you.